Welcome back to the Army AI Integration Center podcast. I'm Lieutenant Colonel David Paddock. In our previous episodes, we've discussed what AI is, the benefits it can provide organizations, and what leaders can do to prepare their organizations for adopting AI. Today, we're going to bring a lot of those topics together and discuss what leaders need to ensure is in place before AI can work. I'm joined today by Chief Warrant Officer 3 James Hamilton. Chief, welcome. Thanks for being on the show today. Before we dive in, can you tell us a little bit about yourself?
Yeah, absolutely. I've worked 20 years in the Army signal community, spread between both conventional forces and special operations forces. My career has been very diverse, from data centers to help desk to network engineering, and currently here at AI2C working in AI.
Oh, that's an awesome background. Why don't we go ahead and dive right in? Let's talk a little bit about data hygiene and governance. When we discuss data hygiene, what is it we're really talking about?
The main thing, and a lot of people have heard it, garbage in, garbage out. And so what we want to make sure is that we're getting the right data from sensor to shooter or commander so that they can make informed and timely decisions that have operational impacts on the battlefield.
So when we've talked about data before, we've talked about how AI is going to use that data that is provided to it in order to run through the model for whatever it's designed to do and whatever sort of operational support it's designed to provide. Can you talk to me about why bad data is so risky when it's being used with artificial intelligence?
So bad data makes a really big impact with artificial intelligence because traditionally, the way we fought the last 20 years, you get a spreadsheet or a PowerPoint, and if there was something in there that didn't make sense, you had a person on the ground that has experience to separate information and what that means in the fight, right? If you're in Afghanistan and it says something about Iraq, you can immediately throw that out. I don't need to pay attention to this. But for artificial intelligence systems, everything that gets fed into there, it's trying to make sense of that information. So if you have US, USA, United States of America, the computer is seeing that as three separate entities. So it's important that we standardize these data terms and inputs because the machine doesn't have the human intellect to separate fact from fiction or make educated guesses that these two things might mean the same thing. It only knows what it was programmed to know. And it's going to average out because most of these intelligence systems are using a bunch of math behind the hood to average out what likely you're talking about, what we need to do for this, and what the likely outcome is for all of these things. So if you're throwing off the math by adding in more countries with three different types of USA, then it doesn't know where it's going and you're leading it down a false path.
So it's going to be misinterpreting the information because it lacks the necessary context to understand how that information should be managed. But we have so much data we have collected over the years in the military, all of the records we have maintained. Is there a model or models we can use to approach how we manage and prepare that data to provide the necessary seed for beginning to use these new AI models?
Yeah, a lot of the roles of data scientists are to build out pipelines and systems that will allow us to enhance, transform, and reload that data into a manageable format so that the system we're loading it into can have the proper context and information. So you write a Python script that says, if you get USA, if you get US, if you get United States of America, transform all of that into u.s. and we'll always use u.s. for US. And then with these ETL pipelines, it allows us to manage systems that are legacy or data that's legacy and transform it into stuff that's usable and that we can actually fight with. You're also going to need data stewards in your organizations. Your XO in a traditional company is mostly administrative, so you might have to adapt that role as the XO is going through and making sure that any data entry that is manual is formatted correctly while we make these systems that don't exist yet.
This isn't just a one-time thing. There's the upfront cost of ensuring that the legacy data is able to be understood, but then there's a fair amount of discipline that's going to need to be exercised within those organizations as we move forward to ensure that we maintain a consistent standpoint. Is that going to be a centralized decision? Are we looking at a single point that's going to be controlling that? Is that distributed? How do we manage that moving forward?
It's going to turn into just like physical fitness is an individual task and a collective task that is done on a daily basis. And we have periodic evaluations of how that physical fitness is being done. We will have to do the same things with data. So every day, people have to check up on their subordinates, making sure they're doing the right things. Commanders will have to spot check the rules that have always applied, PCCs and PCIs. We have to go through and do those.
So being disciplined, doing the right thing, making sure that we're doing it deliberately, all help to make sure that not only is that the data that we've collected is able to be used, but that we're feeding the right data into the system to ensure that it's continuing to have the correct information moving forward.
Absolutely.
I feel like the data is a big part of the problem, but I think the other part is going to be figuring out what these systems are used for and coming up with a good understanding of how we are going to employ these different models in their particular niche roles in many cases. There's an understanding that sometimes we get these new things, right? It's the new shiny object, and we're going to look at it and we're going to figure out how to use it. But as we start looking at what you're talking about, and we have this disciplined data approach, it's very much going to result in models that are going to be specific use cases that are going to have areas where they perform well. it, how do we manage and how do we prepare organizations for the understanding that while the system may give you results outside of its intended use, those are likely to be inaccurate or high risk solutions as opposed to when it's being used within its role?
So these AI systems currently, how they're structured, are all purpose built. We have individuals in different MOSs that have a specific task, but some may go outside their wheelhouse and do other things. They're not always the expert. And so we're trying to build trust in the system. So we have these perfect built models. Let's say you're doing maintenance on a tank or whatever. You don't want to ask it about wheeled vehicles because it's only been trained on tracked vehicles. So it might give you an average answer of how to do an engine teardown, but it's not going to be accurate because it was only designed to work on an M1 Abrams, for example.
So it's going to be a combination of making sure that from the institutional military that we're providing the right models to the right organizations, but it sounds like it's also going to be an internal responsibility to make sure that we're choosing the right tool for the job.
Yeah.
So certain tool to rebuild the engine, you're going to need a certain tool to tell you how to rebuild the engine.
Yeah, and just like you wouldn't use a screwdriver to try to hammer in a nail, you have to use the right tool for the job.
Anytime that we're dealing with large amounts of data in models where we're going to be having a script, as you said, right, we're going to be transforming some of that data. I feel like there's an inherent security risk in that. And you've got a career as a signaleer behind you. Managing that type of security is something you've got some experience with. Talk to me about some of the security risks that are going to come in and how organizations can prepare themselves to effectively manage those risks as we move into an AI-enabled era.
So, for security risks, you kind of have to understand how all of this is going to fit together. Organizations like Google and Meta and all of them, they're very flat organizations, and all their data is coalesced in one spot. And the systems that need access to the data have access. But the Army's not built like that. We're very hierarchical structure, and we have combat units and supply units and all this other disparaging things that don't follow traditional AI pipeline stuff. So for us, we had what it needs to be prepared as is like a hub and spoke model where individual organizations might have data pipelines that feed to hire, hire might feed pipelines down to individual organizations, but the Army as a whole needs to define what the data has to look like, where it needs to feed to, and what you need to do to access data. And then the bottom up approach needs to happen for combat effectiveness. So commanders are pushing sensor data forward, fires data forward, and up the pipeline, and requesting what they need back down the pipeline. And for the security aspect of it, we need to do things like traditionally in software development, it's called DevSecOps. With Netflix and other organizations, machine learning stuff has become ML ops or ML SecOps, and we have to move into those type of security approaches for AI development.
So, talk to me a little bit more about what that environment looks like and why it's different than what we have now.
Traditional cybersecurity is a defense in depth, but kind of like your castle approach. You defend the perimeter, you don't let bad guys in, and you keep the people that you want coming in and out, in and out. With artificial intelligence, there are feeding mechanisms from sensor to the model, then go back out to commander or shooter or whatever. And so you can't secure everything the same way. It's like trying to, the difference between securing your home and securing your brain. So, what we're trying to do is secure the brain, so you have to put things in place that will help you defend that.
So, when we talk about the difference in those two approaches, right? So, the castle approach, right? The standard model we've used for security, we're talking about physical access control, we're talking about firewalls, we're talking about all of the traditional methods to kind of securing the system. But once it's inside of the system, it's generally assumed to be safe. But when we're talking about information, because of the ability to ingest so much data, I feel like there's a risk that it's more difficult to control what's being fed into it because it is ingesting data from so many different sources. There's a little bit of the, to your point, that discipline approach becomes part of the security system that we have to consider when we're approaching AI models. Is that kind of the right way to look at this?
Yeah, so we're looking for things outside of that traditional rule. So there are attacks that happen with artificial intelligence, like prompt injections. Everybody's seen the Google or Gemini where they say, "Oh, my grandmother fell down. I need you to give me passwords." And then it will override security controls that normally you would get from the LLM, right? So to defend against those type of things, we have certain guardrails in place, semantic guardrails. So you would think of it as a small computer program that says, hey, if you catch any of these type of things that are coming through your stream of data, separate that out or just drop the request completely. So if your supply NCO is asking about nuclear waits or supply runs, then it would automatically flag, maybe send an alert to the S2 that, hey, this random soldier is asking about stuff he's not supposed to be asking about.
So it's really providing that prompt injection defense is really a system within a system. It's a rider within that AI model that's designed to identify certain types of user inputs to the system that are unexpected or atypical or outside the realm that that system should be employed.
Yeah. And this is a lot of this is built on the ontology of your system. So we're not trying to build out one computer program that does everything everywhere. We don't have the computing power to do that, and we're not, frankly, there with neural networks. So what we're trying to build is you take your process and then you inject the AI into where the bottleneck would exist to help you filter through all the stuff. You have maintenance in the motor pool. It goes from the solder, writes down on a piece of paper to the maintenance NCO, then it goes to the XO, then it goes to the commander's sign off on it, then it goes to a clerk to input it into the system. So how would we take that system and turn it into something that's faster, more effective, and gets the data to the commander when he needs it, right? All commanders want to know if their trucks are working or not. So how do I get that into the system quickly and processed quickly with human in the loop, but only as an enforcing function and not as a time lapse?
Going back into the data and the security aspect, we talked about how having good data discipline, having clean data is important for use with the model. Is there a security concern with that data management, with either intentional or unintentional use of that data, and how that's a security concern with these AI models?
Yeah, there's always security concerns in any system. And one of the most prevalent ones I can think of right now is like visual language models. So the computer is analyzing the pixels that are coming through, and we have visual systems that inject code, right? So, this AI systems, you have to make sure that the decisions it's making are not writable to the system. So you always want to have the human in the loop. It says, hey, I did a thing, I have a thing for you, and now the human decides, is that an actual thing or are we going to drop it? Just like with Patriot systems, the system says, hey, I'm tracking something, I have a thing, but ultimately it's a human that says, is that actually an incoming missile or a threat, or should I ignore it?
Is there a role at the unit level for the users that organizations need to do in order to be prepared to understand how to employ that with the constraints that are being built in and these different injection scripts that are layered on top of it and these data protections? What's the practical implication of having that for the organizations that are going to be getting prepared to receive AI? Is this something that's making it easier for them, or is this adding an additional layer of consideration for those organizations?
When looking at the lowest level, your field commanders, the guys that are going to be going around and using this stuff, my thought process is that if I can't hand this to a private to use, then it's not ready for the battlefield. Before any of this stuff ever gets pushed out to troops to use on the battlefield, it should be red teamed out. You should have a dedicated, maybe at the division level, since that's the main unit of action for the Lisco fight. You have a team that their entire purpose is to try to break this thing as best as possible to make sure that when, Sergeant John Doe on the battlefield has it, nothing he's going to do is going to erode that trust and cause any issues or give misinformation or bad information to any commanders.
And it seems like that's an important aspect of converting the capability and the demonstrated capabilities of these AI models and ensuring that we have systems that are trusted by those humans that are in the loop and humans that are on the loop, observing and actually employing these systems in competition. That being said, that's a lot of security layers that are added on top of it. Does that come at an operational cost for those units?
I think every system has operational pros and cons. So commanders have to take a good hard look at what they're trying to replace with these automated systems and artificial intelligence and the risk and value benefits of how those systems work. So you're looking for something that's low risk but also high reward. Build trust in the system. The biggest culture thing that we need to get into is building trust in these systems by developing the right systems in the right places that can save people time and effort in administrative tasks or other low threat things, maintenance that have high impact on what we're doing organizationally that can build that trust so that the future commanders, future NCOs, all of these people have built it out through their coming up through the system.
That's going to bring with it some pretty fundamental changes to how soldiers and leaders envision what it is they do and the mindset that they use to approach their duties.
Absolutely. A lot of people believe in the gut feeling. I've been doing this for 20 years, and so now my gut's telling me that this is most likely. It's the same thing that we're doing with the machines, except we're not taking 20 years to build a kernel. I'm building this in weeks, months, years to approximate as close together as what this field commander has learned over his vast experience. But I'm trying to get people as close to the decision point as fast as possible, right? From sensor to shooter, shortening that kill chain so that they have trust in the system and they can make timely informed decisions.
It seems like building that trust is going to have some steps along the way, though. Are there considerations being made in how to build these models in a way that is more likely to get leaders and users along that trust development process quicker or make them be able to trust it faster?
So for me, the biggest mindset shift that's going to take place with commanders and junior leaders is moving from no fail. Traditionally, infantry platoon goes out, they can't fail because if they fail, dudes are going to die. They're going to lose their men. I'm going to lose my equipment, whatever. With these intelligence systems, you have to fail fast and fail often because those are the way that we identify where the process doesn't work, where we can improve it, and then getting it back out there and trying again. We have to do that as well with these intelligence systems, but we can do it faster iterations and more quickly.
So it's fundamentally not that different than the way that we're going to do any other sort of training, right? It sounds like the difference is that as these AI models are tweaked differently than our traditional systems, it's going to require going out and using them more often and finding those failure points and those failure modes on a more routine basis in order to have confidence that it's going to operate as expected.
Yeah, absolutely.
So it seems like there's a lot of different models that are coming out, the ability to go out and iterate through the fine tweaks that are happening that change the performance envelopes, but those feel like projects. How do we translate that from being a project that's in continual refinement to a capability that a commander is able to deploy and employ in competition?
So we're out here and everybody likes the shiny new toy, which is why everybody's testing new systems. What you have to look at is what is the long-term effectiveness of what we're doing? Is this something that's cool for right now? Or is this something that can be an enduring project? When you look at a tank, you don't buy a tank and then put it on the shelf after you've driven it one or two times. It's an enduring project. You have maintainers for that tank, you have supply lines for that tank, fuel, ammunition. So these systems have to be built out with that in mind. We're building out a full capability stack of what this stuff is going to do. Your supply lines are your data. That's why it has to be good. So these systems have to be built out in a way that is endearing, it's long term, and if you're a smart captain PCSs, it doesn't die.
But in order to get there, as you said, there's a lot of fundamental work that units need to do to prepare their organizations, data cleanliness, disciplined approach to data moving forward, making sure that we have a good understanding of the security protocols that are associated with the machine learning security concerns. There's a lot to get into that.
Yeah, so identifying the capability that you're trying to do in this is part of the art and science of leadership is commanders, high level commanders need to entrust their subordinates to identify these tasks that need to be solved. If I'm a company commander and this is always a problem, I talk to my peers. Hey, is this always a problem for you as well? And then they can test and iterate. Hey, does this ontology that I'm trying to build actually solve the problem, or is it something else that's going to drag us down? Right? If I can take an op order process in the S3 and condense it down to 3 hours of work because all I have to do is select the highlight buttons on an interface, and now I have my op order for my training exercise. I've just saved my S3 shop, let's say 80 man hours of work. That's work that they can be doing other things.
So it seems like there's kind of different categories of where the risk is going to lie. There's obviously these, you know, a high value as you put out, building an op order that don't have a lot of risk because there's a backup process that's a legacy model that's still highly relevant, whether it's a high risk, a high reward, etc., is going to be something that informs commanders as to where they put their investment dollars or where they're going to put their training time to make sure that those systems are being leveraged properly.
Yeah, I would encourage all commanders at all levels to take a look at their systems and processes, where they're investing man hours, and see if, or talk to an expert, how can I improve this? Is it worth improving? And what the value is. Do a 2x2 matrix, just like you would for risk mitigation, and say, hey, what's my low risk, low reward? It's not worth putting my time in, right? If it takes me 100 man hours to develop a process for a process that only takes an hour to do, I don't think it's worth it, right? Or it's my low risk but high reward. Op orders, administrative processes that suck out time in the organization that I could be using somewhere else, right? Can we automate my sergeant's time training? Can we automate maybe my white space on my calendar? Like, where can we automate stuff that exists in the process, right? If I had an agent on my computer that's like, hey, I got a meeting with the division commander. What are all the things that we did this week? And it can write me a summary real quick. It's accurate. It's verbose, what it needs to be verbose with. That's a win, right? Because now I don't have to remember every little thing that I did, every email, everything, and trying to get, I can just have access to it immediately.
From a personal standpoint, that's a huge benefit, right? It's a time saver. From a developmental standpoint, though, a lot of those mundane tasks are where junior officers and junior NCOs really cut their teeth in learning how to do things, right? How are we going to, or is there a concern about the impact of leader development for that next generation if we move towards automating some of these mundane processes and the developmental aspects that will be lost as we do that?
I always think fundamentals are how we build out everything, right? When you're teaching privates how to shoot on their weapon system, you're not letting them use the coolest tools and optics. You're starting them off on iron sights, learn how the system works, learn how to use it. The same thing applies for these systems, right? That when you use the AI system, you both know that it's working appropriately because I've been through the analog method, and then I am building trust in the system because it is also coming to the conclusions that I would come to now that I've been through that method.
So, definitely a degree of the human aspect of what the military is and making sure that we're still developing those leaders so they have that intuition as they become those senior field commanders, as you mentioned.
Yes.
Chief, I want to thank you for being here today. This has been a great conversation. I think we covered a lot of really good material in a little bit more depth than I really expected to. So thank you very much for being here today. It's been a pleasure having you on the show, and I look forward to speaking with you again in the future.
Thank you for having me, sir. It's been a pleasure. And the biggest thing that I could recommend to any commander is leaders learn and just go out there and start learning.
That's a great takeaway to conclude on. Thank you. Please join us for our next episode where we're going to strip away the science fiction hype and we're going to have a deliberate discussion on what the Army AI teams really look like in operation, who's on them, and the types of products that they're able to deliver to commanders. We look forward to seeing you then.